Our universe is constantly expanding, making it difficult to establish its limits and measure its size. However, thanks to the James Webb Space Telescope, we can now glimpse into the farthest corners of the universe. Since the James Webb Telescope began its exploration, numerous scientists such as Brian Cox have made announcements revealing the true size and vastness of the universe, which is almost unimaginable. Within the fragment of the universe that we can observe, there are approximately 2 trillion galaxies. This estimate is based on studies of the local universe. We are quite sure that this portion we can see it's only a small part of what we could be an infinite universe that we do not yet know. We are not separate from the universe, but we are an integral part of it. We are in a way in which the universe knows itself. With the help of the James Webb Space Telescope, we plunge into a vast exploration to discover the true size of our universe. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. If we were to travel at a speed of 70 miles per hour, it would take us about 15 days to complete one lap around the Earth's equator. It would take approximately 5 months to reach the Moon, 63 years to reach Mars at its closest point, and at staggering 4,400 years to reach Neptune. These figures alone demonstrate the immense scale of our solar system. To put this in context, we consider the Voyager 1 probe, launched in 1977. At a speed of 38,000 miles per hour, it did not leave the solar system until 2012. This means it spent 35 years just to get out of the solar system. Even light, which can circle the Earth 7 times in a single second, seems relatively slow compared to the vastness of our solar system. And although our solar system is vast, it is dwarfed by the enormity of the Milky Way galaxy. This galaxy contains approximately 300 billion stars, each of which probably has its own planetary systems. Our nearest neighbor star, Alpha Centauri, is 4.3 light years away, which means that if we were to travel at the speed of light, it would take us 4.3 years to get there. Now, imagine how long it would take for us to travel to the next star system, Alpha Centauri. Even if something were traveling at the same speed as the Voyager probe, that is 38,000 miles per hour, it would take a staggering 77,000 years to reach Alpha Centauri. It shows us the immensity of the distances involved in exploring the cosmos. Now, let's focus on Betelgeuse, a star located 640 light years away. If we consider what we call radiosphere, this represents the distance of our radio transmissions have covered in the last century. Although the signals have degraded significantly, they have so far reached about 15,000 star systems. However, this figure is only a fraction compared to the number of stars in the Milky Way, and there is Betelgeuse. If you look at Betelgeuse in the night sky tonight, you are actually seeing the light that left its surface 640 years ago, about 100 years before Columbus set sail for the New World. This light has traveled for all that time, and it's just now reaching our planet. It is truly amazing to realize that Betelgeuse, on an universal scale, is relatively close. To surprise you even more, we must consider that our radiosphere, which encompasses all human radio transmissions, is only a small dot in which the immense expanse of the Milky Way. Let us help imagine this. If we were to reduce our solar system to the size of a quarter of the United States, the entire Milky Way would be comparable to the vastness of our planet. In this immense region, there would be about 300 billion star systems and their planets. We're just one of those 300 billion star systems floating in the midst of an unimaginably large number of stars and planets beyond our galaxy. At least 1 trillion more galaxies. Yes, 1 trillion. 1 trillion is an incredibly large number. To understand its magnitude, imagine a collection of 1,000 cats. Now suppose there are 1,000 groups of cats, each consisting of 1,000 cats. That will give us a total of 1 million cats. But to understand 1 trillion, we must remember that there is already 1 million represented in that number. So 1 trillion equals 1 million times 1 million, which is a staggering number of cats encounters. Our nearest neighboring galaxy is the Andromeda Galaxy, located 2.5 million light years away. Andromeda is rapidly approaching us at a tremendous speed. As this galaxy approaches, our night sky will undergo significant changes. This galaxy contains about 1 trillion stars, and when eventually collides with our own Milky Way galaxy, which has 300 billion stars, the chances of individual stars from both galaxies colliding with each other are quite slim. This illustrates the vastness of space and the low probability of direct interaction between stars within a galaxy. Galactic collisions, although rare at the level of individual stars, may even facilitate light between stars and galaxies. Galaxies are not static systems, but are dynamic and constantly evolving. As we move away from our galaxy, we find our local groups of galaxies, followed by the Virgo cluster, which contains more than 1,500 galaxies. And Virgo, in turn, is part of a larger supercluster known as Laniakea, which contains approximately 100,000 galaxies. Each of these 100,000 galaxies has hundreds of billions of stars and planets of its own. And this is only a small part of the picture. In the observable universe, there are another 10 million superclusters, similar to that. As we zoom out and observe, we discovered an increasing number of mapped galaxies, for example, determined galaxies. However, these mapped galaxies represent only a small fraction of what is really out there. There are a staggering number of hundreds of billions of galaxies that have not yet been fully mapped. In addition, we must consider the cosmic background radiation, which represents the oldest detectable light. For example, that is the residual heat left over from the Big Bang. This radiation is a remnant of the early stages of existence of the universe. The scale of the universe becomes even more staggering when we consider the vastness beyond the galaxies. We find regions in space known as cosmic voids, where matter is scarce compared to the rest of the universe. These cosmic voids are immense, spanning hundreds of millions of light years in diameter, and appear as vast expanses of seemingly empty space. However, these cosmic voids have the potential to give rise to the formation of future structures in galaxies. As we move deeper into the cosmos, we encounter cosmic filaments, which are colossal threads composed of dust, gas, and dark matter that stretched across billions of light years, connecting galaxies and galaxy clusters. These cosmic filaments form a cosmic web-like structure that binds the universe together in the gravitational interactions. The distribution of matter in the universe is not uniform, but shows a cosmic web pattern, where clusters and superclusters of galaxies are connected by these cosmic filaments. This creates an intricate tapestry that spans unimaginable distances. It is within these cosmic filaments and superclusters that galaxies congregate, interacting through gravity. The vastness of space offers a vast and abundant stage for the existence of countless celestial objects and phenomena. For example, supernovae, which are the explosive death of massive stars, disperse heavily elements throughout the cosmos, enriching the interstellar medium and the planetary systems. Black holes, with their immense gravity, play a determinant role in the evolution of galaxies and can release jets of energy that extend great distances into space. In the depths of space, we also find exotic phenomena such as quasars, which are supermassive black holes that feed on intermittent matter and emit colossal amounts of energy. These quasars can eclipse entire galaxies and act as beacons of the early universe, allowing us to study the cosmos in its early stages. However, the question arises as to what lies beyond the observable universe. There are numerous additional galaxies that beyond our visual reach, as the light from these galaxies has not had enough time to reach Earth. Furthermore, due to the continuous expansions of space and the constant motion of galaxies, the light from most of these distant galaxies will never reach us. As a result, these regions may remain inaccessible to us indefinitely. As the universe expands, we can make inferences based on our understanding of the laws of physics. These inferences suggest that the entire universe is at least 250 times larger than the observable universe. In fact, there are compelling arguments suggesting that its size could be even larger, potentially infinite. In this context, a broader perspective emerges that leads us to consider the nature of the universe and our place in it. As human beings on our remote planet, Within the vast expanse of space, contemplating these possibilities invites us to reflect on our existence and our role in the cosmos. Have you ever wondered how vast our universe is? If so, I hope the video has helped you understand even a little bit more about the vastness of the cosmos. I hope you use the comment box to post any questions if you have any. And if you like the video, hit the like button. Share it to reach more people and subscribe so you don't miss more content like this. Thank you so much for watching, and I'll see you in the next one.